This is Mrs. O'Neill for AP Chemistry, Chapter 2, Section 1. Be sure to know the terminology on page 67 of your textbook. Look around at the great variety of colors, textures, and other properties in the materials that surround you. The colors in a garden, the texture of the fabric in your clothes, the solubility of sugar in a cup of coffee, or the transparency and the beauty of a diamond. The materials in our world exhibit a striking and seemingly infinite variety of properties. But how do we understand and explain them? The structure and behavior of atoms are key to understanding both the physical and chemical properties of matter. This can be found on page 39. Hopefully you watched the introductory lesson on atomic models. I took my notes. Hopefully they resemble or are very similar to yours. So Mr. Anderson talked about what a model is. It's a theoretical construct. It's something that our brain kind of comes up with to explain how phenomenon works. So we see something, we collect some data, and in our brains we try to come up with how that works and use a model. So he talked about gravity, and he talked about Einstein, and he said, oh, he saw an apple fall from a tree and land on the ground. So he said, well, gravity is objects that travel the closest path. So again, he made a phenomenon by looking at something that's occurring, formulated some data, did some research, and came up with a model. So if we look at the atom, we want to remember that they are very, 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 very small. We want to know the scientist who gave those models on how the atom works and what's inside of them by using their data and research. So he talked about the atomic model, and Mr. Dalton, the first guy, basically came up with the fact that the atom is a sphere. Rutherford came up with the nucleus in the middle of the atom with his research. The Bohr Model, he came up with the idea that the nucleus is in the middle and that there are rings where those electrons go around or surround the nucleus. Kind of like the solar system. The sun is in the middle and the planets orbit it. Then Mr. Schrödinger, he came up with quantum mechanics. He really came up with the idea that there's a nucleus and the electrons, he basically assigned every single electron a different place in the atom. So, improving what the atom looks like over the years, again, we came up with just a sphere. Thomson came up with the idea of electrons, protons. Rutherford was the nucleus. The Bohr model is like the solar system. And of course, today, the 1930 modern quantum cloud model is what we are still with as of now. So again, this is just another representation. I like this picture where it shows the marble model, the plum pudding model it was called, the nuclear model when they discovered the nucleus, the Bohr model like the planetarium model, and then Schrödinger's model is what we're with today. So he gave you a flow chart on how science works, and he used the atom as an example to fill in the blanks for that flow chart. So he also talked about the Bohr model again and how it helped us come up with the quantum mechanic model. He talked about ionization energy, which we'll talk about in more detail later on in the course, but that's the amount of energy it takes to pull an electron away from an atom. He also talked about the shielding effect and how electrons on the outside are shielded by the inside electrons, and he also talked about the electron-electron repulsion and how they repel each other. So in your notes packet, the objectives here are to appreciate the history and understand the atoms and how they are the smallest piece of matter. So I remind you, you may want to pause the video, fill in the blanks in your packet, and then play to hear my words. So the atomic theory of matter, Democritus really was the very, very first guy. He was around 460 BC, and he came up with the word atomos. He said that all matter is made up of these atomos that are indivisible, meaning we can't break them apart. And then Mr. Dalton, 1803, very, very a long ways away here from 460 BC, he actually was a teacher, an English teacher, but he would read a lot. So he read even in science journals, and he came up with 3 laws that scientists had and used these 3 laws to say, hey, we can actually prove that these atoms exist because of these laws and the evidence that comes from the research. So here is the 4 components of Dalton's atomic theory. Make sure to read over that and understand it. So which one of these 4 are no longer true? Hopefully you picked that one out. All atoms of a given element are identical. This is no longer true. Why? Pause the video and see if you can come up with an answer. The discovery of isotopes. We want to remember that all, I should say most, maybe not all, but all atoms or elements have multiple atoms that would be their element. So we'll talk a little bit more in detail about isotopes later and how the average atomic mass of atoms are calculated because of the isotopes. So of course this is a joke. Let's see what happens. Uh-oh. He drank H2O2. Hopefully you understand that that's hydrogen peroxide. Not very good for you. So how small are these atoms? Sometimes I read journals and find interesting information, or I read some books. And one thing that I found was if you took a grain of rice and you measured it from, end to end, there would be 10 million atoms if you put them like next to each other that would span that length of that piece of rice. So I thought that was interesting. And that's it. Hopefully you'll have some questions for me or not. Maybe you'll understand this fully. Okay,